So this is the Unit 3 review. First question, what is the percent decrease? So percent decrease to the nearest percent of the books checked out from June to July. So percent decrease is the key word. So we have our percent proportion, where we have percent over 100 equals part over whole. Well, this time your percent represents your change. So we have our change over 100% of change. Well, your percent of change is always your greatest number minus your lesser number, which will give you the amount of change. So that's your change 2 over your original. So we have 522 minus 407, which gives you 115 over the original. So June comes before July, so June's our original, over 522. And then we have percent of change over 100. And that can be our x. So now when I cross multiply, I get 115 times 100, which is 11,500 equals 522x. So this is where it's a one-step equation. We're going to divide by 522, divide by 522, and we get x equals 22.03. But it says the nearest percent of the number of books. So the nearest percent is 22%, whole percent. And it is a decrease because it dropped from 522 to 407. So that is your answer. Number 2, it took a dog sled team 8.5 hours to travel 161.5 kilometers. What was the average speed of the sled dog team in miles per hour? So this right here is a unit rate. And we find unit rate by dividing by the per. So in this case, we divide 161.5 by 8.5. And when we divide that out, we get 19. So the average speed is 19 kilometers per hour. So you divide your kilometers by your hours. Number 3, Leora rode 6 rides at the state fair for $19.50. Find the constant of proportionality. So remember, your constant of proportionality is your k. K equals y divided by x. Which, remember, this is also our unit rate. And so we divide 1956 by 6, and we get $3.20. Ooh, that's a 2. $3.26. And really, 3.26 is your constant. Number 4, Matt and Ethan were flying paper airplanes. Matt's airplane threw 36.5 centimeters. How many inches did Matt's airplane fly? So this is a conversion, and with a conversion, we always set up a proportion. And we set up our proportion with our conversion rate first. So we have 1 centimeter equals 0.4 inches. And then we need to know what else we know. Well, we know that 36.5 centimeters, and that goes on top. It matches, if you see right here, centimeters matches centimeters. And then we don't know how many inches there are. So when we solve this, we have 1x equals 0.4 times 30.5 equals 14.6. Divide by 1, divide by 1. The number of inches is 14.6 inches. Number 5, an elephant can weigh up to 7.5 tons. Calculate how many pounds an elephant can weigh. Well, when we look at our star chart, we're looking for how many pounds. So we want to know the number of pounds per ton. Well, when we look at our star chart, we see that 1 ton is 2,000 pounds. And some of y'all might have remembered that off the top of your head. So again, anytime we do conversion rates, set up a proportion. So 1 ton is 2,000 pounds. So you always find your conversion rate with your two different units. And then you put whatever you know. Well, I know that the elephant can weigh up to 7.5 tons. And so we want to know how many pounds is that. So when I solve this proportion, I get 15,000 pounds. So number 6, the question is saying the table below shows Kimberly's budget last month. About what percent of Kimberly's monthly budget was spent on health insurance? Well, first, so it's a percent problem. So anytime there's a percent, we set up our percent proportion, where we have our part to whole over, or equals 100 or percent over 100. Well, in this case, our total is 1,100. So I don't know my percent. So that's is where we're going to put X at. So X goes over 100. My part is the health insurance. And so she spends $90 on health insurance. My whole for the monthly budget is going to be 1,100. So when I solve this proportion, I get 1,100x equals 9,000. And so when I divide 9,000 by 1,100, I get about X equals, where the percent is about 8%. So 8% is how much she spends on health insurance each month. Number 7, Mark bought a new Chevrolet truck for $20,400. The sales tax was 7%. How much was the truck including tax? And so first thing I need to find is my tax. And I find that by setting up my percent proportion. So I have 7% over 100, and then 2,400 goes on bottom, because your part, your 7% represents the tax. And so when we solve that proportion, we get that the tax is for 1,428. Well, in order to figure out the total for the truck, you take the cost of the truck, which is 20,400, and you add the sales tax, because remember, sales tax is something that we pay on goods that we purchase. So it gets added back in there. And so the total sales price on a truck that Mark is buying is $21,828. A Dallas Cowboys football player can run at a rate of 45 yards in 4.5 seconds. What is the constant rate of change? And so if we remember this, constant is our K. So we take K equals Y divided by X. Y divided by X. In this case, our Y is 45 yards. Our X is 4.5 seconds. So when we divide that, he goes 10 yards a second, or per second. So, if we can complete our table, so seconds is our x, yards is our y. So in order to find our y, we take our k times x. Well, we already found our k to be 10. So I'm just multiplying x by 10 each time. So 0 times 10 is 0, 1 times 10 is 10, 2 times 10 is 20, 3 times 10 is 30, 4 times 10 is 40, 5 times 10 is 50. So if we write our equation, it's just that. It's y equals 10x. We are multiplying x by 10 each time. We're multiplying our seconds by 10 in order to get our yards, because he can run 10 yards per second. So how do I graph that? Well, this represents his seconds. Sorry, not yards. This represents the x, which is your seconds. And then your y is represented by your yards. So in 1 second, he goes 10 yards. 0 seconds, 0. 20 seconds, he goes 20 yards. 30 seconds, he goes 30 yards. 40 seconds, he goes 40 yards. Oops, that did not mark. 50 seconds, he goes, or 5 seconds, he goes 50. So that is our proportional line. It's straight and it goes to our origin. It says, put a star where your constant of proportionality is. So our constant proportionality is 10 yards per second. So I want to put my star where yards is 10, which is right there. Oh, I skipped the question. There it is. Number 9. Blake wants to save $4,000 in 1 year on a new house. He earns $3,250 each month. What percentage of Blake's earnings should he save so that he can have enough down payment for a house? Alright, so this is one of those questions where they try to trick us. So again, it's percent per equation. So we want percent over 100 equals part over whole. So in this case, we know that we don't know our percent in over 100, and we know that his income is $3,250. But his percent right here represents his savings per month. Well, it doesn't talk about savings per month. This is savings per year. But we can easily get that down to a month, because how many months are there in a year? Well, there are 12 months in a year. So in order how to figure out per month, I just divide those out. I divide 4,500 by 12. And so he needs to save $375 per month. So I'm going to put $375 over his monthly income, and then I'm going to solve my proportion. So when I solve my proportion, that's not as pretty as highlighting. I get 37,500 equals 3,250 times x. Divide by 3,250. Divide by 3,250. And we get that the savings per month is 11.5%. So you need to save about 11.5% of his money. Another way you could have also done this is, instead of dividing your savings per year by 12, you could have multiplied how much he earned per month by 12. It would have given you the same answer, as long as you had set your proportion up correctly still. Number 11, there are about 11 football fields in 1 mile. If Lewis ran 12 miles, Which equation can be used to calculate the equivalent amount of football fields Lewis ran? Alright, so my screen messed up, so I don't have the answer choices up here, but I can still set up this proportion. So I have 17 fields in 1 mile. So that's my conversion rate. That's one of my ratios. Well, if Lewis ran, so that's one of them. If Lewis ran 12 miles, 12 miles goes on bottom with 1 mile. And then I don't know my top. So this could be the proportion I could set up in order to solve this equation. Number 12. Haley collected music boxes when she was 8 years old. She has 35 music boxes. 80% of them are Disney themed, 10% of them have different city names, and 10% of them are sports themed. She has 35 total. I'm going to underline that. The 8 years old really doesn't matter. How many boxes are Disney themed? So, if we're dealing with percent, so we have our percent proportion. Now I just need to know what is the question asking for. Well, it's asking for Disney theme, so I know my percent of Disney theme. I know it's 80% out of 100. So I need my whole. My whole is going to be the 35 music boxes. And then my X is going to be how many are the Disney. So those are Disney. 80% is Disney. So when I want to highlight it. When I cross multiply, I get 35 times 80, which is 2, oops, I'm still drawing with my highlighter. 2,800 equals 100x. So when I divide by 100x, I get that there are 28 Disney themed boxes. Number 13, Spencer is playing cards with her mom. She has won 14 games out of all the games played. If Spencer won 65% of the game plays, how many games did her and her mom play? So, it's percent proportion. So we set up our percent, which is 65 over 100. So 65 represents the games Stephanie won. Or Spencer won, sorry. Spencer won. So, 65% of the games. Well, 14 represents how many games she's won. And so, our 100% is the total games played. And so, I can solve this by cross-multiplying. When I cross-multiply, I get 65x equals 1,400. Divide by 65. I get x equals 21.5. Well, since there can't be a half a game, we can round up to and say about 22 games, that they played about 22 games. In Stephanie's class, 4 out of 5 students have purple pencils. If there are 25 students in Stephanie's class, which of these proportions could not be used to find the number of students who have purple pencils? Alright, so again, my answers didn't show up on the screen, but I can set up a proportion that could work, and I can possibly show all the variations. So we have 4 out of 5, and so your 5 represents your total number of students. 25 also represents that, so you'll have x like this. You could also write this ratio as x over 4 equals 25 over 5. You could also write this as 25 over x equals 4 over 5. You could write this as x over 25 equals 80 out of 100. All these ways are the same thing because they're ratios. They can be manipulated but still give you the same answers. 15. Julia went to go buy her fall pumpkins in September. They cost $6.52 for each pumpkin, but in the month of September, the pumpkins were selling at a 15% cheaper price. How much were the pumpkins selling for in December? So they cost $62, $6.52. They were selling at a 15% cheaper price. Right? So if it's a cheaper price, if it is a cheaper price, that means it's a discount. So again, we find percent of a number. So we have 15%, and your X is going to represent your discount. And so we get a 15% discount. And we don't know our discount, so that's why it's X. But I do know how much they originally cost, which is $6.52. So I can multiply, cross multiply, get 100X equals $6.52 times 15, which is 97.80. Divide by 100. Divide by 100. You get that the discount is about 98 cents. And so it doesn't say how much was the discount. It says how much were they selling for. So then we have to take our original price and subtract our 98 cents. And we always line up decimal points when we're subtracting decimals. And so I'm going to subtract this. 12 minus 8 is 4. 14 minus 9 is 5. Bring my decimal down, I get 5. So the cost of the pumpkins in September is $5.54. Number 16, Shane rode his bicycle at a constant rate of 15 miles per hour. Show the graph, which graph shows the distance Shane traveled. So, remember, a constant rate is proportional. Proportional lines have to have two characteristics. It has to be straight and go through the origin. So A is automatically not it. It needs to go through origin. It doesn't. Okay. Then we need to find where 1 is 15. So on B, 1 is 15. On C, 1 is not 15. So on our first hour, he does not ride 15 miles per hour. He rides something up here, and that's just not correct. So you have to have the dot 115. The graph point of that one, for every 1 mile or 1 hour, it has to go 15 miles. And sadly, this one does not. But this one does. It has 115. Alright, and then if we look at answer choice D, at x equals 1, it doesn't have 115 either. So D is not our answer. So B has to be our answer. Good luck on your test. Hope you study hard.